Great. So, like I said, let's get started. So, welcome to making predictive judgments with a wine-themed dataset and Daniel Kahneman's noise. My name is Laura, and I'm happy to have you here. So, just to show you the book as well. So, that is the book that we're going to be talking about today. Kahneman is one of my favorites, really. I first got onto him when I was reading Thinking Fast and Slow, which I highly recommend as well. It's so good. But the one that really piqued my interest in regards to this meetup is noise, actually, because there was a little study that he mentioned. I'll go into more detail in a bit. It's really, really cool. And just to give you an overview of what we're doing today. So first, I'll give a little, not a literature review, but more like a rundown of Kahneman's main points regarding judgments and models. And after that, we're going to look at a wine-themed data set. And we're going to look at the libraries. We're going to explore a little bit. And then we're going to make an attempt at predicting wine quality. And the code editor that I'll be using today is VS Code. Just a little note. Okay. And so, just talking about Kahneman, first of all. So he has, in chapter 9, which is dedicated to predictive judgments, he makes the distinction between predictions made by professionals and machines and simple rules. And just to give you his main points. So when he talks about professionals, he talks about something called clinical judgment. That's the technical term. And these are expert opinions uttered by respect experts. So for example, doctors or professional forecasters. And for most people, they are immediately intuitive. And then the study that he mentions in his book is about executive management judgments. So what he describes is there are doctoral level psychologists. So not just people from the street, right? Really highly educated people. And they are given a scorecard of management executives. And they have different categories that they're categorized by. For example, leadership skills, leadership skills and communication skills, persuasiveness, and they are given scores. And then based on the scores, the doctoral level psychologists, the experts come up with predictions how and whether this person will do well as a manager. And what Kahneman notes is that in the study, the professionals are actually coming out last. So the predictions that they give are barely better than chance. So barely better than flip of a coin, really, which is kind of shocking, I guess. And then the next instance of predictive judgments that he mentions are machines. And what he talks about when he means machines is mechanical predictions made by highly sophisticated artificial intelligence models. And they help simulate complex situations. And what he notes is that even a model of you is more accurate than you. And the reason why that is, as he says, is because a model is more consistent and it is less noisy. What he means by noisy is that, for example, when you're hungry, or for example, when you're cold, or the time of day, or the decision that you've made previously, all add to a noise. It is not bias, it's quite different. It's a very interesting concept if you're interested in human judgment and psychology. And then the last instance that he mentions when it comes to predictive judgments is simple rules. What he means by that is sort of trivial formulas, simple models, kind of like rule of thumb models. And he notes that when you apply them consistently, they outdo clinical judgment by a mile. but they are a little bit less accurate than machines. He calls them the workhorses of judgment and decision-making research. And then one of these simple rules that he mentions is multiple regression. And multiple regression is a technique that is useful when you're predicting the values of a variable from its relationship with other variables. And we're going to look into that in a minute. What I've done is I've pulled this data set on wine quality, and there are several features in that data set that go into predicting the rating, how highly the wine is rated. I'm going to look at that in a minute. And yeah, that's it for the literature review. So I'm just about to move on to Kaggle and VS Code. And before I do that, I just want to quickly check the chat. Are there any questions? Is there anything that you want me to go back to? Anything you want me to quote directly? Anything you want me to explain, perhaps? Only reason I'm asking is I feel that I tend to talk quite fast, and it can be a bit quick for some people. Hi, Tom. Yeah, no, that's fine. Cool name, by the way. Is that your real name? If that's not a rude question, no. Okay. Fair enough. Did you watch Top Gun? You did. I haven't watched it yet. Shame on me. Okay. If you don't have any further questions, I would just get right into it, if you don't mind. Yep. Okay. You're good. Okay. All right. Okay. In that case, let me just share that screen again. Just one sec. Where are we? Right. Okay. Oh, there we go. So we've just got our little banner on the top for illustrative purposes. Okay. Can I just ask, right? Are you just here to watch and sort of think along, or do you actually want to code along? Do you actually want to do something on your own machines, just for me to sort of have an indication of how slow or how fast I'm going to get? You're both watching. Yeah, that's fine. That's fine. In that case, I'll I'm just going to be cruising through it, and yeah, if you want me to go over something, I'll ask you, and we'll see what happens. Okay, so the first thing that I did was I got this data set here, and just to have a quick look at the source. Oh dear, can you hold on? Let me just can you see that? Sorry, can you see the Kaggle site now? Hold on. Oh dear. I think you're just seeing my VS Code. 1 second. Let me try again. Hoo-hoo. Hoo-hoo. Okay, let's do that again. Where are we? Not here. Right. There you go. So if we just have a look at the Kaggle set. So here we have it. It's about wine quality. It says on the top red wine, but then further down it says white wine as well. I'm not sure. Okay. And it is a little bit older. It is from, it says here, red and white variants of the Portuguese Vinho Verde wine. So we're talking specifically about Portuguese wine from 2009. Okay. And there are, it says here, due to privacy and logistic issues, only physico-chemical inputs and sensory variables are available. There is no data about grape types, wine brand, wine selling price, etc. Okay, so it is a bit limited in that sense, but let's just have a look at the actual data. So the first thing that I did was I imported my libraries. I've got pandas, matplotlib. So pandas to kind of deal with the mathematics side of things, matplotlib and seaborn to sort of visualize what we're doing. Can you see the code editor? Sorry, just to make sure. Let me do the, you could do it, okay. Let me just go back to just the code editor maybe. I think that's easier. Okay, yeah. So we've got seaborn, and then we've got scikit-learn, we've got linear regression, and we've got this train test split library here, just to sort of split our data. We'll have a look at that in a minute. Okay, so the first thing that I did was I downloaded the data set from Kaggle, and I read it in, and then I just had a quick little look. So we have a bunch of features, and well, presumably they influence the quality of the wine. We have several features relating to acidity. We've got fixed acidity, so what is always in the wine. Volatile acidity is sort of acid that dissipates, that evaporates as you oxidize the wine. Citric acid is basically, what lemon juice is made of, basically. Residual sugar, so how much sugar is in the wine when you drink it, how sweet is it, basically. Chlorides. Chlorides relates to preservation of the wine, same with sulfur dioxides and sulfates. So these are chemical compounds that winemakers put in to sort of prevent the wine from spoiling. Density is how watery is it. So the higher the number, the less watery it is. pH is does it have a low pH? That means it's probably going to be maybe more acidic tasting. If it has a higher pH, maybe it's less acidic tasting. Alcohol is how many percent alcohol does it have? And then quality is the rating. And the quality is a scale from 0 to 10. And then as we have a look, the first couple of wines have sort of average ratings. They're not really that great. They're not really that bad. 10 being the highest and 0 being the lowest. Okay. And let me just have a look at the chat. Yep. Everything okay so far? Does that all make sense up until here? Yep. Okay. All right, so then the next thing I did was, so when I checked on Kaggle, it already gave a perfect score for the data set in terms of usability. And I just had a look myself. So we've got 1,599 entries. We've got 12 columns in total, and we have no data missing. And the data that we have is discrete numbers, and then we have integers for the quality. So yeah, everything is really clean. We don't have to convert any data types. Everything's there. And just to be sure, we've got no data missing. It's just a really easy to use data set. There's no cleanup. And then so the next thing I did was what I wanted to find out from the data set was I wanted to find out what are some factors that make for a good wine, or maybe what makes a bad wine, on the contrary. And then also, how are the ratings distributed? Okay. And how the ratings are distributed, that was a really easy task. So I just had a look at the value counts, and value counts gives you the data points available and what percentage they are. And then if we have a look, right? So 42, almost half of all wines are just rated a 5, like an average. And then another 40% roughly are rated a 6. And then 12% are rated 7. And then everything else, so 4 and 8 and 3. So really good ratings and really bad ratings are somehow the outliers. And just to sort of, oh, what's happening here? Okay. And so just to visualize that as well, it's a relatively normal distribution. So most wines have a sort of average rating, and then really good and really bad wines are kind of, yeah, rare to come across. So, okay. I would say no surprises here. I have to say, I was maybe a little bit surprised in that there were no wines that were rated 9 or 10, and there were no wines that are rated 1 or 2. So that was interesting, the only interesting bit. Okay. And then so I want to be quite honest. So like I said, I'm not a professional. I'm just doing this as a hobby, and you know, I'm just really enjoying it as a hobby. But I'm not really great at anything, right? So I know there are things for feature selection methods that help you pick the best features from a data set so you can predict properly. And they are filter, wrapper, and embedded methods. And I'm going to have to be honest, that is far above my skill level. And so what I've decided to do instead is to normalize the data frame and then look at and explore each feature individually. And so what I mean by normalization is I did a minimum maximum normalization. So for every feature, for every column in the data set, the minimum value becomes 0 and the maximum value becomes 1. And then so every other feature value becomes a value between 0 and 1. Okay, so just a really simple formula here to normalize it. And what I'm going to show you the graphs in a minute, but just to give you my preliminary conclusions, if wine has medium or higher levels of these features, then it appears to have higher ratings in terms of quality. And then if it has higher levels of these bits, it means that it seems to indicate that the rating of the quality is lower. Okay, so what I concluded from my graphs was that people don't really like sweet wines, and they don't really like the taste of chemicals such as chlorides or sulfates. Can I just ask, are you wine drinkers? Do you drink wine yourself? Do you have any experience, maybe as a sommelier or that kind of thing? Not much. I'm going to have to be honest. I'm more of a beer and whiskey person myself. More of a very casual drinker. Oh, you're in the Philippines. You prefer sweet ones? Okay. A beer and a shot. Okay. Interesting. So generally what I found that wines seem to get better ratings if they're not sour, okay? But they should still be a little bit basic, but there should still be some kick from the acidity and the alcohol. So there should be some bite. It shouldn't be too cloying, and the alcohol level should be a little bit higher. And they should be not sweet. They shouldn't be not watery. They should have a nice mouthfeel, kind of like a dense mouthfeel. That appears from looking at my graphs what people like. So what I did is I selected the features, and the features are down here, except I'm excluding the last one being quality, because quality is not a feature. It's the predictor variable is what we want to find out. So I excluded it from the features up here. And what I did next is I did a little loop. And for each feature in these features, I made a graph. I made a scatter plot and X being the feature on the x-axis, and then on the y-axis, the quality. The data frame for each is the normalized data frame. The quality shows us the color, and then the size is how often this feature occurs. And alpha refers to how transparent the plot point, the data point is. Just to give you an example. Okay, so here we go. For example, here we have fixed acidity. And if we have a little look, so as fixed acidity increases, quality, or sort of, if we're in the sort of medium to high range, quality seems to be higher. The quality rating seems to increase a little bit. Okay. Let me just quickly check the chat. Any questions? No. Okay. You're good. Okay. So I've done that. I'm not going to go into each graph. I think it's just going to be a bit boring, and I don't want to keep it too long. So boop, 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 boop. That's what it does. La, 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 la. Okay. But yeah, so what I then did was build a really simple multiple regression model. Again, using the normalized data, using the features and the quality as the predictor variable. So I create a multiple linear regression object here. And then I take my data, X and Y, and I split it into training sets and test sets. Okay. The training size being 0.8 and the test size being 0.2. And I then fit my data. And then what I then do is I score my data. And then what I find, unfortunately, so if we have a look here, so the score means if you have a score that is 0.7 or 70%, that is considered good. My score comes out at 0.4, so 40%, which is not good at all. It's, yeah. So all the features combined account for only 40% of the variance. And so what I then did was I looked at the coefficients, and the coefficients tell us which variables carry the most weight. And then looking at these numbers up here, the last two features seem to carry the most weight. The last two features are, where are they? Hold on, just to remind us of the features. Sulfates and alcohol, I believe. Which are, yeah. So sulfates and alcohol have the highest coefficients, so they seem to have the highest influence, right? And so what I did was just to kind of, I imagined a wine and put in a couple of scores, and I gave the model really high values for sulfates and for alcohol, and then it gives me a really high score as a result. But what I'm not quite happy with, right? So what I'm imagining now is I have a wine that has a lot of sulfates and a lot of alcohol, and I have to say it does not sound like a wine I would want to drink. And again, because my model only has 40% on the score method, I just don't think it's a very reliable model. So the conclusions that I came to in the end, so the model is not reliable, and I'm not really going to put much importance on its predictive powers. So not just a grain of salt, more like a lump of salt. And what I think at the moment, so first of all, either my model is terrible, which is a possibility, highly possible. Another possibility is that there are features that are not in the data set that influence quality. And what I have found, if you look at, for example, sommeliers or how people judge wine, right? Um, they have had, for example, studies of wine experts where they took white wine and they used food coloring and made it look like red wine, right? And then these experts, they all thought it was red wine. Okay? Or, for example, there have been academic studies where they looked into the surroundings that people have. Yeah, it's true. The surroundings, right? So, for example, let's say you are on holidays, right? And you go visit a vineyard and you are sitting outside, dining al fresco, nice meal, maybe with your spouse or whatever, you're having a really good time, you're enjoying that wine. And because of the surroundings, you really enjoy the wine, right? But then once you get home, you have a bottle of wine at home and it's just, I don't know, all by yourself. Suddenly the wine doesn't taste as good. So what I'm thinking is wine has so many variables, so many features that it's just really hard to predict the quality. That is my personal conclusion that I've drawn from the data and also from what I've seen academically. Yeah, and yeah, that's pretty much it. We're kind of at the end, like I scheduled. Do you want me to go back to anything? Do you want me to explain anything? Yeah, you're good. No worries. So what I'm going to do is I will upload this bad boy to GitHub. I'm going to send a message to everyone who RSVP'd with a link to the GitHub, and then maybe you can have a look on your own time just to kind of maybe explore it. Yeah, and if you have a message, if you want to say anything, you can message me. That's totally fine. It's a little bit above your head. Yeah. Yeah, let me send it out maybe on GitHub, maybe just to kind of go over it in on your own time and have a little look. Okay. I'm just going to stop recording now. 3, 2, 1.